Okay, good day. Good evening, everyone. Today we are doing the third lesson of heat. Third lesson. Okay. Up to now. Okay. Shall I recall your memory? So we were discussing about what will happen. Suppose there's a material. So if we apply or if we give heat energy, if we supply heat energy to this material, then what would be the mechanism of receiving this heat energy? That is the thing we were discussing about in our previous class. Okay. Then I will ask some questions from you. Okay. Okay. Tell me. Once I supply heat energy to a material, so what is the first thing happen inside the material? What is the first thing? Tell me. Total, total internal energy will be increased, but the thing where among that total internal energy, what will be the factor?
Kinetic energy.
Yeah.
Increase.
Yes. Yes, Shruti. Very good. Once I supply heat energy to this material, the first thing is the kinetic energy of those particles will be increased. No? That is the thing, and that is the first thing. Then due to this kinetic energy increment, what can you see or what can you feel?
The temperature would be increasing?
Yes, very good. Because the temperature is a measurement or temperature is a sensation that depends on the kinetic energy of particles. Therefore, when the kinetic energy increases, temperature also increases, because temperature is a sensation that depends on the kinetic energy. Then, if I further supply heat energy to this material, then what would be the next step?
The particles vibrate more and more.
Particles one more. Then
at a certain point, the bond will be break.
Yes, very good. At a certain point, the bonds or intermolecular bonds start to break. Then after that, what will happen?
Change of state occurs?
Change of state of occurs. Yes, very good. Okay, then when the change of state occurs, then what can you see or what can you observe?
No change in temperature during that period.
No change in temperature during that period. The reason of that? The reason?
That heat energy is used to break the intermolecular bonds.
Yeah. Then? Give me a complete answer.
The kinetic energy remains constant because the temperature is constant.
Yes. No, the temperature is constant. Kinetic energy is constant because the entire heat energy is used for break the bonds. That is the reason kinetic energy is constant. Okay. Kinetic energy is constant because the total heat energy, the entire heat energy supply, which is supplied at that point, is used to break intermolecular bonds. Okay, therefore no change in kinetic energy. No change in kinetic energy means no change in temperature because temperature depends on kinetic energy. That is the argument. Okay, so that is it. Okay, then that heat energy absorbed by that material during that phase changing state, we call a special name for that heat energy. What is that?
Latent heat.
Yes, very good. I don't remember this one whether I taught you or not. But I think you can give this you answer. Okay. Normally, there are two kind of heat, latent heats. No. What are those?
Latent
Sir,
heat
can you
of
repeat?
vaporization.
There are two type of latent heats. What are the name of those?
Latent heat of fusion and vaporization.
Yes, latent heat of fusion and latent heat of vaporization. Latent heat of fusion comes when a solid material become a liquid. When a solid material becomes a liquid, the heat energy which that is used to convert this this solid material to liquid is called as the latent heat of fusion. This is fusion. Latent heat of fusion. Then, once this liquid material becomes a gas, the absorbed heat energy during this phase change is called as latent heat of vaporization. Yes, vaporization. But the vaporization, because this is a vapor. This is latent heat of vaporization. I think I have given this name, no? In our note. As I remember, we have drawn some picture, no? Figure.
Sir, we have drawn the graph on this, but we haven't identified the terms, sir, as latent heat of fusion
No.
and
Before that graph, I have given you some stepwise pictures. No?
yes, sir, yes.
In that pictures, I think I have given that name. No.
So in the graph, we mark latent fusion heat and latent vaporization heat. In the before diagrams, we didn't mark this.
Okay. Okay. So I think some students write that name in graph and others in pictures. Okay. Anyway, you have to write that name in both cases, in picture as well as in the figure as well as the graph. Okay. So latent heat of fusion. Latent heat of fusion means when a solid materials completely converted into a liquid, the absorbed energy during this phase change is called as latent heat of fusion. Latent heat of fusion. So if the graph, if we consider the graph, I think I have separated these zones, no? Have I separated zone?
Yes, sir.
This is solid, ne? This one is solid. This one is solid. This is called as latent heat of fusion. Latent heat of fusion. Latent heat of fusion. Latent heat of fusion. Not the area. Okay, not the area. I mean, the heat absorbed during this period is called as latent heat of fusion. So don't misunderstand that one. Okay, this is not the area. This is not the area. I wanted to mark the heat energy absorbed during this period is called as latent heat of fusion. So if I consider the phase during this phase, during this period, we can have a solid liquid mix. It is solid liquid mix. Something like semi-solid. Okay. Solid liquid mix. There are solid as well as liquid within that. Okay. You can clearly understand. You can get the understanding when an ice cube, when ice cube is melting, you can see this one. Ice cube is melting. There may be some water as well as some solid ice. Then, after this period, the solid material is completely converted into a liquid. Therefore, this phase is a liquid phase. Liquid phase. Then, after some time, the liquid phase is completely converted into a gas state. Gas state. In between those two states, the phase changing moment. So the heat absorbed during this phase change is called as latent heat of vaporization. After that period, after that level, then this is the gas state. This is the gas state. This one is gas state. Gas state. Okay. If you did not mention those things, this is temperature, Buddha. This is temperature. This is given heat. Okay. This is the given heat, and this is the temperature. Okay. Okay. Normally, this one means latent heat of vaporization. Latent heat of vaporization is higher than latent heat of fusion. Normally, latent heat of vaporization is higher than latent heat of fusion. Can anyone guess the reason for that? The latent heat of fusion, so latent heat of vaporization is higher than latent heat of fusion. Why? What is the reason?
Because the strength of breaking the bonds when converting liquid to gas is greater when compared to the strength of breaking the bonds when converting solid to liquid.
Yeah. So the complete answer. Can anyone guess? So this is a solid material. Solid material means it is a completely packed material. So if it is converted into a gas, then water, liquid, then the particle will be arranged something like this. Then, when the liquid material is converted into a gas, what will happen? All the bonds will be broken. All the bonds will be broken. Now, can you guess the answer? Can you get the answer? Can you guess the answer? Yes, the number of bonds. The number of bonds will take. The number of bonds, because when a solid material is converted into a liquid, actually we do not want to break all the bonds. We do not want to break all the bonds. Therefore, when a solid material converted into a liquid, there are some amount of bonds will be broken. Okay, but when a liquid is converted into a gas, all the bonds should be broken. Okay, therefore, the number of bonds broken in this process is lesser than the number of bonds broken in this process. Therefore, due to this reason, the heat absorbed during this process must be higher than the heat absorbed in this process. Okay. Did you get my point? This is very important thing. Okay. This is very important thing because there may be questions. There may be questions regarding this knowledge. Okay. Now the direct questions. Okay. The examiner may want to ask what is the higher latent heat, whether it is a latent fusion or latent heat of vaporization. They won't ask that part. But the thing is, you have to use that knowledge when you are distribute some answers. Okay. Therefore, this knowledge is very important knowledge. You have to mark that thing. Very, very important part. Okay. So when a solid material is converted into a liquid, there are some amount of bonds will be broken. But when a gas material is converted, when a liquid material is converted into a gas, the entire bonds, all the bonds, all the intermolecular bonds must be broken. Therefore, number of bonds broken in the second process is higher than this one. Okay. Okay. Then we can write some note about latent heat. Okay, latent heat. Normally, latent heat of fusion and latent heat of vaporization is defined for 1 per 1 kilogram mass. Okay, because you can understand this one. When the mass increases, the number of particles will be increased. No, when the mass increases, Everyone, please look at the board. Very important things. Very interesting questions. But beyond the gas state, still we did not find any other state. Okay, any other state. But the thing is, when you describe these things using the modern physics, those descriptions will be changed. Okay, therefore you don't want to consider about those states. This is conventional physics. This is conventional physics. So, according to conventional physics, this is the explanation. But when you are learning the quantum physics or modern physics, especially particle physics, the explanation might be changed. Okay. But to understand that physics, you have to have very good knowledge about conventional physics. Otherwise, you cannot understand modern physics. Okay. Okay. Yeah, strength of bond is matter. But the thing is, the number of bonds, the number of intermolecular bonds broken in this case is much higher than this case. Okay. Therefore, the strength change. Yeah, actually there might be strength change, but that factor is minor factor. So this is the major factor affected to this incident. Okay, because this model is formed or is created according to the observation we got during this practical. During this practical means, suppose you are going to melt ice until it gets vaporized. Okay. So you can do this practical. You can get a solid ice. Then you can give a heat. And measure the temperature of that material. Then you can draw this graph for solid ice until it gets vaporized. Okay. So from the practical, you can clearly observe the latent heat of vaporization is higher than latent heat of fusion. Okay. You can do this practical for any material. Then the result will be same. So according to that result, we build a hypothetical concept. That is the thing. Okay. Actually, we cannot go into a molecular state, and we cannot get the observation in molecular state. We cannot get any observation in molecular state. We cannot see that now. So those are some hypothetical concepts using the observation we got during those kind of practicals. Okay. You get my point? We can do a lot of practicals regarding this incident. That means we can get any kind of solid and we can do heat until it gets vaporized. Okay. So then we can plot the graph between the supplied heat and temperature. Then you will have the same graph. And you can clearly see the latent heat of vaporization is higher than latent heat of fusion for every material. Okay. Therefore, then we can build a concept, hypothetical concept using this observation. So that is the way of building concepts in physics. Okay. Okay. So that is the difference between Newton's physics and modern physics, because in modern physics we cannot do practical. We cannot do practicals. We cannot do we cannot do actual physical practical. Okay, physical practical means we have to imagine lot of things and build up concepts. So the modern physics are based on imaginary concepts. Okay. Hi. So that is the reason behind the magnitude difference between latent heat of vaporization and latent heat of fusion. Okay. What I was discussing about the mass. Okay. So when the mass increases, everyone, please look at the board. Everyone. When the mass increases, what will happen? When the mass increases, the number of particles increases. No, the number of particles increases mean the number of bonds, the number of intermolecular bonds in between those particles increases. So when mass increases, number of bonds increases. Therefore, when those kind of phase changes happen, the absorbed heat energy will be higher, will be increased when increase in the mass, Therefore, if you want to define latent heat, latent heat, we have to consider a unit mass. Then it is much more meaningful because when the mass increases, the heat absorbed during phase change increases. Okay. Did you get my point? Okay. Then write a topic. Latent heat. Right under that. The heat energy. The heat energy that is absorbed during a phase change. Is called every phase change is called latent heat. Latent heat means the absorbed energy during the phase change. Then it can be classified into two categories according to the phase change. Okay? If it is solid to liquid phase change, then it is called as latent heat of fusion. If it is liquid to gas phase change, it is called as latent heat of vaporization. Okay. Then write in another para.
Excuse me,
Yes.
what's the meaning of
Sorry?
So what is meant by
But I cannot hear you. Your voice is not clear. Hello. No, it is phase change. It is a phase change. Okay, phase change means it is a common name, Buddha. Okay. It is a common word. There are two types of phase change. Then I will mainly discuss that thing. Okay. Okay, write in another paragraph. Another paragraph. The latent heat that associate with solid to liquid phase change is called latent heat of fusion. Is called latent heat of fusion. In another paragraph, the latent heat which is absorbed during liquid to gas conversion is called latent heat of vaporization. Latent heat of vaporization. But in another rule, when the mass of a material increases, the number of particles increases. I will discuss it. when the number of particle increases, the number of intermolecular bonds increases. Therefore, the required heat energy for a phase change, must be increased. Therefore, the latent heat is defined for a unit mass.
Excuse me, sir.
Yeah.
Sir, can you repeat the last point, please?
Therefore, the latent heat yes, very good. You got the one. Therefore, the latent heat is defined for a unit mass.
Thank you, sir.
Okay. All right. Write in another paragraph. You are right, Puta. When a solid material when a solid material is converted into a liquid, some amount of intermolecular bonds will be broken. Will be broken. But when a liquid,
Sir, can you repeat the
but when a liquid,
those are the previous?
sorry, the first sentence.
Sir.
Okay.
When a solid
Okay, I will repeat that one. When a solid material is converted into a liquid, some amount of bonds will be broken. But when a liquid is converted into a gas, all the intermolecular bonds will be broken. Therefore, number of intermolecular bonds broken in solid to liquid transition is lesser than number of intermolecular bonds broken in liquid to gas transition. Okay. Therefore, heat required solid to liquid Correct. Okay, look at this one. Therefore, number of intermolecular bonds broken in solid to liquid transition is lesser than number of intermolecular bonds broken in liquid to gas transition Putta. Therefore, heat required because number of moles are lesser. Therefore, heat required for solid to liquid phase change is lesser than heat required to liquid to gas phase change. Therefore, latent heat of fusion is lesser than latent heat of vaporization. Latent heat of vaporization. Okay. This is very important theory part. Okay, write down this thing.
Sir,
Yeah.
when state changes also the mass of solid is equal to mass of liquid, isn't it? Correct?
Oh, sorry. Very good question. You have to consider there is no any mass change. Okay, mass change. That means suppose when you are converting solid into liquid. So suppose you are converting the ice cube into a gas into a water. Okay. Then there is a required heat energy to convert that ice cube into a liquid. Once you convert it into a liquid totally, suppose you are going to add another water into this water state. Okay. Then this equation is not valid. Okay. This is valid when you consider a unit mass. Unit mass means when you consider a constant mass is converted into a solid from solid to gas. Okay. Okay. You have to convert a constant mass. You have to convert constant mass throughout the entire process. Okay. Throughout the process. Okay. Otherwise, if the mass change, this will change. Okay. Therefore, you have to keep the mass of solid state as a constant. That is very good question. I will be the point. Okay. Once you write this in equation, write this under this. You have to keep the mass. You have to keep the mass as a constant throughout these processes. Okay. What will happen if the mass change? If the mass change, then definitely the required heat changes. Okay. Because what is the reason for that? Because when the mass varies, the number of intermolecular bonds will be vary. Okay, that is the reason for that. Okay. Did you get my point, everyone? Did you get my point?
Yes, sir.
How about it? A. Now, write another topic. Write another topic. Thermal contact of two bodies. Thermally contact of two bodies. Thermally contact. Okay. So what is the meaning of thermally contact? Thermally contact. Contact. You know about contact, no? So what is the meaning of thermally contact? Thermally contact can come. So thermally contact. Can anyone give me an answer? You can guess and give me an answer. Thermally contact.
Contact between two.
Yeah.
A contact where the heat transfer is possible.
Yes. Yes. That means if there are two masses, or if there are two bodies in this space, in such a way that the heat of one object can be transferred into the other object, we call it as thermal contact. Thermal contact. Okay. So thermal contact means it may be a physical contact or it may not be a physical contact. Okay. Suppose you are closer to fire. Then you can actually feel the hotness of that fire. No, you can feel the hotness. So that means you and that fire are in thermal contact. That's why you feel the hotness of that fire. Okay. So thermal contact means actually it may be a physical contact or it may not be a physical contact, because there are three ways of heat transferring. There are three ways of heat transferring. What are those? Tell me. Yes, very good. Conduction, convection, and radiation. Conduction, convection, and radiation. Okay. You know, if it is conduction definitely you should have a physical contact. The conduction requires a physical contact. But if the heat transfers through convection and radiation methods, it doesn't require a physical contact. Okay, this doesn't require a physical contact. Okay, therefore, thermal contact may be a physical contact, or it may not be a physical contact, but the heat energy can be transferred from one body to another. Okay. So write down this. Write down this. If two bodies, if two bodies exist if two bodies exist in such a way that the heat energy that the heat energy that the heat energy that the heat energy from one object from one object can go to the other object comma that is called a thermally contact. That is called a thermally. That is called a thermal contact. Thermal, not thermally. Thermal contact. A thermal contact is not always a physical contact. Is not always a physical contact. Because there are three ways of heat transferring. There are three ways of heat transferring. Write down this trick with this one. Right. Okay, write down under this one. Therefore, Therefore, heat can be transferred. Heat can be transferred without a physical contact. Without a physical contact.
So can you please repeat the point?
Therefore, heat can be transferred. It can be transferred without a physical contact. Without a physical contact. When you write down these three methods, you have to write down this one also. Physical contact, doesn't require physical contact. Okay. Now tell me some examples of two objects that are in thermal contact. Please give me some examples. No, mass doesn't change, Bhutan. How would it ever? Mass? It doesn't change. From the when solid convert into a liquid, mass doesn't change. If you add some water to the converted liquid, then it may, yeah, density change and volume change. Mass is a constant. Density will be changed. Due to the change of density, then the volume change. Okay, not the mass. Okay. If there is a change in mass, you have to have additional particle or you have to lose particles. That is the thing. Okay. If there is a mass change, definitely there should be a additional particles or there should be a loss of particles. Okay. So, is there any additional particle or is there any loss of particle? Particle loss unada, add unada. Addition? Is there any addition of particles?
No.
No. Therefore, the mass doesn't change. The mass doesn't change if you add some particle. Okay. If you add or remove particles, then mass will be changed. But until then, mass doesn't change. Okay. Mass doesn't change.
Okay.
But there is a special clause. What is that? What is that? There should not be any vaporization. There should not be any vaporization within that process. Okay. If there is a vaporization, definitely the mass will be changed because some particle will go to the gas phase. Okay. So therefore, if there is not if there is no any vaporization in between this process, then mass is a constant. Mass is a constant. And මොකක්ද මේ ඔයගොල්ලෝ නිකන් අර water එක heat කරනකොට උඩ මේක ඕපන් කරගෙන heat කරන්න එපා. එතකොට කොහොමවත් ඉතින් මේ vaporization යනනේ පුතේ මේ atmosphere එකට. එතකොට ඉතින් mass එක change වෙනවා. එහෙම නෙවෙයි මම කතා කරන්නේ. Suppose when you heat up a liquid, with open beaker, then definitely there will be a mass loss of mass, because the vaporization can be occurred and those vapors can be added to the atmosphere. Okay, so I'm not actually the previous case is not like this. Okay, the mass is a constant. The mass is a constant until you keep it as a constant. No. When you heat in water, suppose you can keep some certain water level. You can keep some certain water amount. Okay, then actually, suppose if you keep the water level is something like this. So if you convert this into a gas, then there will be some minimum amount of gas. Okay, so the increment of pressure will be within a safe limit. Okay, so but if you convert a huge amount of water, then there will be huge amount of vapor particles. So due to the number of particles, the pressure will be increased. Then it will be a disaster. Okay, so you can keep this water level as you require. Okay. Okay. Please look at the board. Okay. Now our topic is thermal contact of two bodies. Okay. Can anyone give me a example or examples for thermal contact bodies? For examples. Thermal contact means heat energy can be transferred from one object to other. Yes. The top. Yes. That's all right. If we are closer to a fire, then we may feel that hotness. Then if you put some hot material into a liquid, then the temperature of that liquid increases. Okay. Yeah. All correct. Okay. Very good. Again, look at the board again. Suppose now there are two objects, A and B. Now there are two objects, A and B. Both are in thermally contact with each other. That means the heat energy of one object can flow into the other. Heat can be flow into the other. So the heat energy of A can flow to B. Right? So what will be the mechanism? What will be a mechanism? So what is the mechanism of flowing of this heat energy? Hmm? Can anyone guess? Can anyone guess? What will happen? Suppose, okay. Another question. If suppose now they are in thermal contact. Okay, now they are in thermal contact. Suppose now they are in thermal contact, and tell me if there is a heat transfer from A to B, what would be the requirement to be fulfilled?
The temperature of A should be higher than B.
Temperature of A should be higher than B. Very good. Temperature of A, suppose it is 50 Celsius, should be higher than that of B. So what is the theory behind that? So this is the observation, Muta. This is your observation. If the temperature of A is higher than temperature of B, then definitely there will be a heat transferring between A and B. A and B. So what will be the theory behind that? Temperature. If there's a temperature difference, concentration.
The amplitude of particles vibrating due to heat energy is higher at A than B.
Then amplitude is higher, then yes, you are correct, Steve. Energy flows from higher to low. That is the answer, eh? Normally, energy flows from higher to low, Muta. That is some simple theory. And normally, energy flows from higher energy to lower energy. If temperature is higher in B, then so if the temperature of A is higher than temperature of B, that means the kinetic energy of A, is higher than that of B. Okay.
Sir, if we consider that A has a lot of mass than B, and the energy was higher due to its mass, but the temperature is lower, the heat flow should be occurred from B to A, no, sir? Because it doesn't depend on the energy, it depends on the temperature, heat flow.
No, it doesn't. It depends on energy, not the temperature. Okay. Temperature depends on energy. Kinetic energy, Buddha. Temperature depends on kinetic energy. If the kinetic energy increase, temperature increase. Okay. Temperature is a sensation that depends on kinetic energy of particle. If the kinetic energy increases, temperature increases with that. Okay. Temperature is not the physical quantity. Actually, it is a physical quantity, but it is a sensation. Okay. Not a specific feature. Okay. But if the kinetic energy increases, temperature increases according to the kinetic energy. Okay. So that means the temperature of A is higher than that of B. That means the kinetic energy of particles in A is higher than that of B. Did you get my point? The temperature, not the factor, actual temperature is a dependent factor. It is not an independent factor. It depends on the kinetic energy. Temperature depends on the kinetic energy. Okay. If the kinetic energy increases, temperature increases. Kinetic energy means the vibration of particles. If the vibration of particle increases, the temperature increases with that. Okay. Did you get my point?
Yes, sir.
Sir,
Yeah.
So for that, the object B should be a conductor, no? Thermal conductor.
Yeah, it should have thermal conductivity. Because any material, any kind of material has thermal conductivity. The thermal conductivity, the magnitude of thermal conductivity varies with the material. But any material has a thermal conductivity. Okay. You can hold up some wooden rod. Suppose you are. So there's a fire. You can hold a wooden rod. Suppose this is a wood. Wood or some kind of low heat conducting material, and suppose there's a metal. Okay. Actually, if you keep a metal like this, actually you can feel the hotness very quickly than in wood. But you can feel the hotness after some time, or that is a matter of time. It is a matter of time, not the matter of energy. It is matter of time. This material has a heat conductivity, but the conductivity of heat is lesser than the conductivity of metal. That's the thing. Okay. Every material has a heat conductivity. All the materials has a heat conductivity, but the amount of that heat conductivity will be varied. Okay. It is not like electrical conductivity. It is not like electrical conductivity. Electrical conductivity is very different thing. Very different thing. Did you get my point, Hiroshima?
Yes, sir.
Okay. Hi. If we consider you mean sea breeze and ground breeze. So what are the two bodies which are in thermal contact with them in this case? Thermal contacted objects. What are those? If you consider sea breeze and ground breeze, land and beyond. No. Is there land and water? No. No. Then, so what are the two bodies that are in thermal contact? No. Actually, Pute, for any heat transferring, any heat transferring, there should be two bodies. There should be two bodies involved with the heat transferring. Not only convection, but also radiation as well as conduction. You have to have two bodies. Otherwise, there won't be transferring. Okay? If there is a transferring means that heat transfer should be occurred from higher point to lower point. Therefore, definitely there should be two ends. Okay, definitely there should be two ends. Okay. So my question is, what are the two ends? What are the two ends? Did you get my point, too? Definitely, there should be a two ends if it is a heat transfer. Okay. So you are discussing about convection, but not only conduction, but also conduction and radiation. If there is a heat transferring means the heat energy go from one material to another material. Therefore, definitely there should be a thermal contact. There should be thermal contact between two bodies. Okay.
Yes, sir, but in sea breeze and land breeze, it's just the air on top of the sea and the ground, sir.
Yeah.
It's just the air on top of the ground and the sea, sir. So it's just the air, sir. So is
No,
there
if
two
you
objects
consider
involved?
breeze, then it is the air on the top of the ground. If you consider breeze, okay. So I am not talking about the breeze, okay. I am considering the reason for breeze. So what is the reason for breeze?
The rotation of the air.
Hmm? So what is the reason for sea breeze or ground breeze?
The heat energy difference, the heat difference.
Yeah, there is a heat. Actually, there is a thermal contact between sun and seawater as sun and ground. Okay? Sun and sea and sun and ground. There is a thermal contact between. This is the ground. There is a thermal contact between water and sunlight and ground and sunlight. Due to this thermal contact, the topmost surface in both sides, the temperature of top surfaces will be increased. Due to this temperature increment, what will happen? Due to this temperature increment, the air molecules near to sea water will be transferred to the upward direction because due to this radiation or due to this thermal contact between water and sea, the temperature of topmost surface will be increased. So due to this increment of temperature, there will be a void space because the air molecules will be going upward direction. Will go upward direction in upward direction. So there will be some vacuum space. So due to this vacuum space, definitely there is a pressure difference. There is a pressure difference. Due to this pressure difference, there will be a breeze. Breeze is occurred due to pressure difference. It is not due to the thermal contact between two objects. Okay, it is occurred due to pressure difference, but the pressure difference occurred due to the thermal contact between sun and ground and sun and sea. Sun and ground and sun and sea. Did you get my point?
Yes.
Okay. Okay. Then what I was discussing about flowing of heat, no? Okay. So due to the temperature difference, we can get an idea. If the temperature increases, definitely the kinetic energy of the particles in A is higher than the kinetic energy of particles in B. That means kinetic energy of particles in A is higher than the kinetic energy of particles in B. Kinetic energy means that is heat, no? So kinetic energy means heat. That means the heat energy of A is higher than the heat energy of B. Yes, that is seen during day. After that, see. Okay. Okay. I will discuss. Look at this one. So in this case, kinetic energy of A is higher than the kinetic energy of B. What is the reason? We can clearly identify the temperature of A is higher than temperature of B. That means kinetic energy of A is higher than kinetic energy of B. Kinetic energy means heat. Therefore, heat energy of A is higher than heat energy of B. Heat energy of B. Okay. Therefore, the heat energy of A is higher than heat energy of B. Therefore, due to this heat difference, due to this energy difference, energy flows from the higher point to the lower point. Energy flows from the higher point to the lower point. Okay. Due to this energy flow, the energy of A decreases and energy of B increases. Okay. So due to this energy flow, energy of A decreases and energy of B increases. Actually, energy of A means kinetic energy of A. Kinetic energy of A decreases. Kinetic energy of the particles of B increases. So due to this reason, the temperature of A decreases because the kinetic energy is going down. Therefore, kinetic energy depends on temperature. Therefore, the temperature of A decreases and temperature of B Now it is increasing. Okay. And then what will happen? Then after some time, both particles or both material becomes equal temperature material. That means the temperature of A, after some time, temperature of A will be equal to temperature of B. Temperature of A is equal to temperature of B. That means the kinetic energy of the particles in A is equal to the kinetic energy of the particles in B. Therefore, heat energy in A is equal to heat energy in B. Yes. Yes. So in this case, both material have equal heat energies. So due to this reason, now there is no any net heat flow. Net heat flow means total heat flow. The net heat flow will be zero. The heat flow will be zero. Until then, there was a heat flow from A to B. From A to B. After that, after this point, the net heat flow will be zero. Okay. So this point is called as thermal equilibrium point. Thermal equilibrium point. Okay. Did you get my point? Another. There are the topic. Topic. Flow of heat. Flow of heat from one object to another. From one object to another. One object to another. Okay. All right. You can draw the first image. Okay, I will explain that today. Okay.
Excuse me, sir.
Yes, madam.
When both the temperatures are equal, after that, it again further does not increase, right? After both the temperatures become equal in A and B, that means they come to one temperature, then again further it does not increase, right?
No, because there's no any net heat flow. There's no any net heat flow. Therefore, due to this reason, after the thermal equilibrium, there won't be any temperature changes. There won't be any temperature changes. Okay. Yeah.
Okay, sir. Thank you, sir.
Okay. Write down this one. Consider. Yes, sir. Yeah, you have to draw this first one. Draw write this one. You have to draw the first image. You have to draw the first image only. Don't write anything. Don't write anything. Just draw this image. Just draw this image. Okay, write down under that image. Consider the two objects A and B. Consider the two objects A and B, which are in thermal contact. Which are in thermal contact. Which the temperature of A is 50 Celsius and temperature of B is 30 Celsius. Okay. Okay, with it. Temperature means don't write the temperature means kinetic energy because kinetic temperature depends on kinetic energy. Temperature depends on kinetic energy. Therefore, you know the temperature. Temperature depends on kinetic energy. Kinetic energy. So therefore, kinetic energy of particle A is higher than kinetic energy of particle B. Therefore, heat energy of A is higher than heat energy of B. Okay. Right up to this point, don't write this one. Right up to this point. Temperature depends on what temperature directly proportional to kinetic energy. Therefore, kinetic energy of particle A is higher than kinetic energy of particle B. Okay. Write down on that one. Energy flows. Yes. Yeah. Energy flows. After in this one, you will have better. Energy flows from higher point to the lower point. From higher point to the lower point. Therefore, heat energy, the heat energy in object A in object A it starts to flow towards the B, towards the B. Okay, I will repeat that one. Okay, I will repeat that one. Energy flows from a higher point to a lower point. No? As I remember it, energy flows from higher point to a lower point. Therefore, heat energy of A, it starts to flow towards the B, Okay, write in another graph. Due to this reason, kinetic energy of particles in A will be decreased, and the kinetic energy of particles in B,
Sir, can you repeat the last sentence?
due
Due to this reason.
to this reason, the kinetic energy of particle A, kinetic energy of particles in A will be decreased, and kinetic energy of particles in B will be increased. Okay, kinetic energy of particle A, kinetic energy of particles in A decreases and B increases. So due to this reason, temperature of A decreases and temperature of B increases. Write down this thing. Okay. Then now we can have a small break. Today I'm not going to do. I'm not going to give a spot quick recap. So please come within 10 minutes. Please come within 10 minutes. Okay, that means 9:35. 9:35. We will start. Now get a small break. Thank you. Okay, all. Okay. There is another explanation about the previous question also. So this Q equal MC theta. Q equal MC theta implies the heat energy transferred from one object to other. One object to other. That doesn't imply the heat energy which is inside the material. Okay. They are two different things. They are two different things. Okay. Suppose the heat energy inside this material, depends on the kinetic energy as well as the potential energy. Okay. It is not this Q. This Q and the heat energy is two different things. Two different things. Okay. Therefore, don't think, don't use this equation to describe this thing. Okay. Don't use this equation to describe this thing. This Q equal MC theta implies the heat energy transferred from one material to other. So one material to other means suppose I will give an example. Suppose this is example. Okay? This is true example. Okay. The heat energy inside this material is 500 joule. 500 joule. Okay. 500 joule means suppose the kinetic energy is 300 and potential energy is 200. Okay. This is just an example. Okay. This is just an example. Now, don't ask how does it happen. Okay. And, this is an example. The total energy is 500, kinetic energy is 300, and potential energy is 200. Okay. Then there's another material here. The total energy is suppose 200. The kinetic energy is suppose it is 50 joule. Then potential energy is 150 joule. Okay. Okay. Initial potential energy doesn't change. Normally, potential energy changes when there is a state change. And, so due to the difference in kinetic energy, there will be a heat flow from here to here. There will be heat flow from here to here. Okay. That means this heat flow is due to the different kinetic energy. So once the kinetic energy is transferred from here to here to here, what will happen? There is a heat change. There is a heat change. So this heat change is represented by Q in this equation. This heat change is represented by Q in this equation, not this one, and not this one. Okay. That's why you cannot describe the heat energy inside this material using this equation. Did you get my point? Did you get my point?
Yes.
Which I am not.
So that means that kinetic energy transfer between two objects is equal Q, no?
Sorry, Budhi?
Kinetic energy transfer between two objects is equal to Q, no, sir?
Equal to Q means it is represented by Q, Buddha. It is represented by Q. That is another part. Okay, that is another part. I will describe that thing. But until then, there's a question. No? The question was regarding this equation. I think question was if C changes, then if there is suppose this one is 100, theta is 2, then the answer is 200. So that answer that 200 can be get if it is 50 and theta is 4. No? If C is 50, theta is 4, the answer is 200. And if C is 100, theta is 2, or answer is 202. So you can have both values for different theta values. No, that was the initial question. And so answer is you cannot do that. You cannot do that because Q means this one. Q means this one. Heat transferring occurred due to the difference in heat energies between these two particles, these two objects. Okay. Therefore, this Q equal MC theta implies the heat transfer from here to here, not the heat energy inside that material. Okay. Did you get my point, Buddha? Which I am not. I cannot see your name.
Yes, sir.
Okay. Okay. I will explain this thing when we are doing Q equal MC theta. Then you can understand very clearly. Right? Okay. Then write the topic. Thermal equilibrium. Write down this one. According to the previous example, the heat flow occurs from A to B, from A to B. Due to this heat flow, the temperature of A,
Excuse me, sir, due to the
due to this heat flow, the temperature of A decreases and the temperature of B increases. After some time, the temperature of both objects, becomes equal. Temperature of okay, I will repeat that one. Temperature of A decreases and temperature of B increases. Then after some time, the temperature of both objects, becomes equal. Write in another paragraph. Temperature depends on kinetic energy. Temperature depends on the kinetic energy. So heat energy converted to kinetic energy? No, dude. Heat energy is the kinetic energy. This is not this mechanical kinetic energy. This is not actually. This is a kinetic energy. This is a vibrational kinetic energy, which is inside the material. Okay, so heat energy means the kinetic energy plus the potential energy of the particles. Okay, therefore, kinetic energy is a part of heat energy. Therefore, there is no any conversion of kinetic energy into heat because heat is kinetic energy. And the kinetic energy of that inner particle. So, do you get my point? Why? Heat means, actually, heat means if you supply a energy, when you supply energy, if the kinetic energy of that particle, if the kinetic energy or potential energy of inner particle can be changed by a energy, that energy is called as heat. So heat is a energy that can change the kinetic energy or potential energy of inner particle. Okay, therefore it is a type of both kinetic and potential energies. Okay, when we supply a heat energy, due to that heat energy, the kinetic energy can be changed or increased. Okay, that is not a conversion. That is not a conversion. That is a giving of extra kinetic energy. Okay. And you have to imagine that one because we cannot get a practical example here. Actually, we can increase kinetic energy by giving in another type of kinetic energy. Okay. Another kinetic energy. Okay. Okay. What was the last sentence?
Temperature depends on kinetic energy. So
So the kinetic energies of particles, in both materials, are equal now. Kinetic energy of A is equal kinetic energy of B. Kinetic energy of B. Okay. Actually, when there is a heat transferring without phase change, that occurs due to the difference in kinetic energy. Okay, I will explain that thing in Q equal MC theta equation. Then you will actually you will have a lot of answers for your questions. Okay. How? Then the kinetic energy of A is equal kinetic energy of B. That means there is no any difference in energy. So if there is no any difference in energies, then there won't be any net heat flow. There won't be any net heat flow. Okay. Net heat flow means actually heat can be in the at this way point, heat can be transferred from A to B and B to A. Can be transferred, but the thing is the net value is 0. That means the heat energy transferred from A to B is equal heat energy is transferred from B to A. In this case, thermal equilibrium is something like this. It is actually, we can consider it as a 1 unit. When it is a thermal equilibrium, we can consider them as a 1 unit. Therefore, heat can be transferred, actually heat can be circulate throughout the unit. Heat can be circulate throughout the unit. That means the energy can be circulate throughout the unit. But there is no any net heat flow. Net heat flow. But there is a heat flow from A to B and B to A. A to B and B to A. So, because there's a heat thermal contact. There's a thermal contact between A and B. Due to this thermal contact, definitely there should be a contact through heat between A and B. Okay. But when it is in thermal equilibrium, the heat transferred from A to B is equal heat transferred from B to A. Okay. Did you get my point? Okay. Then write down this one. This point is called as thermal equilibrium point. This point is called as thermal equilibrium point. Okay, draw this one. Okay. Write down under that. When two objects are in, when two objects are in thermal equilibrium condition, there is no net energy transfer between two objects. There's no net energy transfer between two objects. Okay. But there are energy transfers. From A to B and B to A. but both should be equal. Both should be equal. Should be equal. Repeat means from which point? But there are heat transfers from A to B and B to A. From A to B and B to A. But they are equal to each other. They are equal to each other. So there is no net energy transfer, but so there is no net energy transfer at this point. At this point. Correct. Okay. Now we know about thermal equilibrium. Then about how to exchange heat, not exchange, how to flow heat from one object to another object. Then from which point to the? Okay. Okay. Suppose now there is a heat exchange. Heat exchange means heat transfer from one object to another object. From one object to another object. That's a heat transfer. One object to another object. Suppose during this heat transfer, there is no any phase change. There is no any phase change. Okay. Without a phase change, a heat energy is transferred from one object to another object. Okay. Now we are going to determine what are the factors that affect to this heat energy. The heat energy. So what are the factors that affect this heat energy? Okay. Hi. Actually, now we are going to discuss the answers of your previous questions. Okay. Hi. So write a topic. Write topic. Determining the factors. Determine the factors that affect to the heat energy, that affect to the heat energy given to an object without a phase change, Okay. Before that, I had to mention one thing. Now there is no any phase change. So due to this heat exchange between two materials, there is no any phase change. Okay, please concern that thing. This is very important thing. Okay, due to this heat exchange, now there is no any heat exchange. Sorry, now there's no any phase change. That means due to this heat exchange or heat transfer, the only energy type that was changed is kinetic energy. Okay, so because there is no any phase change, therefore the potential energy is constant. So the only factor, the only energy type that is changed during this heat exchange is kinetic energy. Therefore, this is totally about kinetic energy. Totally about kinetic energy. So, if you give a heat, or if you give a heat to an object, or if you remove a heat energy from an object, the first thing happen is the changing kinetic energy. So until there is a phase change, the only energy type that changes is kinetic energy. Therefore, under this topic, we are discussing about the changes of kinetic energy, not total heat, that is only for kinetic energy. Write this one under the topic. If there's no any phase change, sorry, topic. You want repeat the topic, Buddha? Yes. Okay, I will repeat that one. Can anyone repeat that topic, Buddha? Actually, it is
Determine the factors that affect to the heat energy given to an object without a phase change.
Thank you.
Welcome.
Determine the factors that affect to the heat energy given to an object without a phase change. Right under that. This is very important. Okay. Okay. In this case, there is no any phase change. There's no any phase change. That means no change in potential energy. No change in the potential energy. No change in the potential energy. Therefore, the kinetic energy is the only factor, that is change due to the supplied heat,
Can you repeat the last? From that means
That means the kinetic energy is the only factor. So is only the kinetic. Therefore, the kinetic energy is the only energy type. Is the only
So you said it's the only factor that is changed due to the supplied heat.
and it should be the only energy type, not the factor. This is right, the only energy type. Okay, it is only the energy type that is changed due to this heat energy. No? Okay. So due to this heat energy, due to this supplied heat, there is an energy change. There is an energy change in kinetic energy only. Okay. So now we are going to consider only the kinetic energy. Okay. So this is not about the total energy. This is about the kinetic energy. And now we are going to determine factors that affect to kinetic energy change during the heat exchange. The first factor. suppose there are two different masses, and we have to increase their temperature from 0 to 40. From 0 to 40. The material are same. We have to increase material same. Material is same. And suppose we have to increase the temperature of this material from 0 to 40. 0 to 40. That means we have to increase the temperature of each material. We have to increase the temperature of each material from 0 to 40. That means if you consider this material, you have to increase the temperature from 0 to 40. From 0 to 40. 0 to 40. Suppose if you need 10 joule to increase one particle, to increase the strength of, increase the kinetic energy of one particle from 0 to 40, then 1, 2, 3, 4, 5, 6. That means you need 60 joule to convert the entire material from 0 to 40. No? Did you get my point? This is assumption.
Sir, can you repeat it?
Suppose now my objective is increasing the temperature of this material from 0 to 40. 0 to 40. And suppose there are 6 particles inside the materials. Okay? Inside the material. So if you want to increase this temperature from 0 to 40, that means you have to increase the temperature of this particle from 0 to 40. This particle from 0 to 40. This particle from 0 to 40. So if you increase the temperature of this particle, definitely you have to supply an energy. Suppose the energy required to increase the kinetic energy of this particle from 0 Celsius to 40 Celsius is equal to 10 joule. Okay. Then this particle also require 10 joule. This one also require 10 joule. This one also require. This one also require. This one also require. That means if one particle requires 10 joule to increase this temperature, then the entire material requires 60 joule to increase the temperature from 0 to 60, 0 to 40. Then, did you get my point? Clear? Others?
Good, sir.
Anita? Okay. Yerishika?
Yes, sir.
Oh, Yerusha. Yerusha මොකද? ඉන්නවද? Okay. Hi. Okay, suppose now we have another material. The mass of that material is something higher than this one. So mass increases mean the number of particles should be increased. Therefore, in this case, there are only 6 particles. But In this case, definitely the number of particles should be increased. The number of particles should be increased. 1, 2, 3, 4, 5, 6, 7, 10, 11, 12. So there are 25 particles. That means one particle requires 10 joule. One particle requires 10 joule. Therefore, we have to give 250 joule. 250 joule to increase the temperature of this material from 0 to 40. From 0 to 40. Right? Because I have taken the same material for in both cases, but only thing is the mass is higher in this one than this one. Okay. Therefore, when mass increases, number of particles increases means we have to give more energy to bring that particle from one temperature to another higher temperature. Okay. Did you get my point? Everyone, I need responses. Right,
Yes, sir.
thank you. Janusha, Viraj. Okay. Same material. Okay. Now we can determine. What are the factors? That affect to the value of Q. The value of Q. Okay.
X gives the value of
Q. Q2, Q1. Okay. Draw this image. Okay. Suppose there are two masses. There are two masses. At 0 Celsius, there are two masses at 0 Celsius. And need to increase their temperature, up to 40 Celsius, up to 40 Celsius. Up to 40 Celsius. Both are made of same material. Both are made of same material. Right in another paragraph. As the mass increases, the number of particle increases. The number of particle increases. The number of particle increases. Suppose there are two masses, two different masses. No? Suppose there are two different masses at 0 Celsius, and we have to increase their temperature up to 40 Celsius. And both are made of same material. But in another paragraph, as the mass increases, number of particles increases. Number of particles increases. If the number of particles increases, we have to give more heat energy. We have to give more heat energy we have to give more heat energy. To bring those particles from 0 to 40 Celsius. To bring those particles from 0 to 40 Celsius. Within bracket. The kinetic energy difference. The kinetic energy difference of one particle is equal in both cases. But the number of particles are higher in the second material. Number of particles are higher in second material. Can anyone may repeat the last sentence?
But the number of particles are higher in the second material.
Number of particles are higher in the second material. Therefore, we need more energy in second case. We need more energy in the second case. Close the bracket.
So therefore we
Need more heat energy, more energy in the second case. That therefore we can say Q means the heat energy depends on number of particles. When number of particles increases, heat energy increases also. So heat energy depends on number of particles. Number of particles means the mass. Therefore, Q directly proportional to the mass. By this one. Have it. Okay, Buddha. Now we can complete today's class after I think this one. Because I think now all of you are right, no? So we can complete today's class. The extra class for the class we missed in last week is scheduled on Tuesday. Tuesday means the next Tuesday. And there's another class. There's another class means a repeat class in Saturday because some students cannot participate in Tuesdays. Therefore, there's another class on Saturday. Okay. I will inform the time. So those are the extra classes. Then this next Sunday, and okay, that's all. Do you have any questions to ask? Okay. Big button, maybe I have. Yes, Tuesday එක තමයි Sunday එක Saturday කරන්නේ. Tuesday කියලා කියන්නේ මොකක් කට්ටිය සමහරවිට බැරි අවස්ථා තිබෙන මුත් ඒකයි. හරි. ඒක මොකද මේ ඒකයි Saturday මම දාගත්තේ මම ඒක පොඩ්ඩක් බලන්න මොන අර time source එක මොනවද මතක නැහැ ඔයගොල්ලොත් ඒක discuss කරපු time source එක මම select කියනවා ඔයගොල්ලන්ට. හරි. Okay. You will have answers for your previous questions in next week because once we discuss these things, then I can explain all the things very clearly. Otherwise, sometimes I cannot explain without explaining those terms. Okay. Okay. Then we can continue to discuss with that. So, good night. And I walk.
Thank you, sir. Good night.
Good night. Welcome.